Hi, welcome back. I hope you stopped the first video and watched the link videos on extreme value and absolute value theory. That'll kind of get you to where we are mathematically. So we're gonna go ahead and just go right into the second part of the zero theory experience here. So, as always, we're gonna draw a point, and we won't discuss what that point is until the next series, because we all know what the point is. Alright, so by drawing a graph here, a grid, I have went ahead and depicted the 360-degree infatuation that I have, that our mathematics has had, and that the Mayans have had and do have. I wanted to go ahead and start with the drawing of our favorite function. And in this series, I will actually tell you why it's my favorite function for a couple of reasons. This function is important to me because I understand orbitals. So mathematically speaking, this is an important function for multiple reasons. Not only does the Mobius band kind of cast a net for us, which we will go ahead and discuss here in a moment when we talk about CERN, but it also is a perfect depiction of some of the most coolest electron orbitals. And if you love electron orbitals as much as I do, then you have memorized the different orbitals. They're not the same type of math that we go by, if you know what I mean. But electron orbitals allow us to visualize the particle movement of photons, because remember, as we talked about previously, in the photoelectronic effect, they not only move as particles, but waves. But wait a minute. Before we go ahead and get to that, let me make sure I covered the rest of the points here. Yes, so now that we've depicted the potential movement of an electron in an orbital, as well as why it's my favorite function, because of that, then you can understand basically crystallification, and we don't want to talk about that immediately. That's basically the part of Kim 1 that they give you and they just throw it in the trash. You're like, ah, ha, 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 yeah, don't worry about it. You want to worry about SI? You want to know about how crystals form? Don't worry about that. Worry about the theoretical movement of particles, not the actual tangible part. So now that I've gotten that ran out the way, I wanted to go ahead and perfectly segue into the shadow realm, which for our purposes I will now depict in, let's go ahead and say, this dark blue color. So as I depict this in a dark blue, okay, now don't make fun of me when it comes to it really goes like this. Okay, don't laugh. Alright, so as I depict that in the blue, I want you guys to kind of imagine a cosmetic mirror. That's two-sided, that's two-faced. And you imagine that mirror to emphasize your entire self, right? And on one side. On the other side, I want you to imagine that it's minimalized. That's a joke. It's a hypnotist joke. You need to understand that the shadow side is not dependent of the reflection on the opposite side. Now, here's what I'm going at. If you found a blemish in the larger perspective. Understand that blemish is independent of your thought. That's just a glimpse of the shadow realm. I love how I just use that. But no, in a more scientific standpoint, you need to understand that the shadow realm is independent of the reflection that we use to determine it. And that's hard because that's like we said, this is zero theory. This is seeing yourself either as a zero or your environment as a zero. Um, we're gonna go into the whole quantifying that soon, but just continue to imagine you being independently disgraceful, if that makes any sense. Anyway, I think we should end there because we will go into, actually no, let's keep going. So yeah, the string theory is also a perfect demonstration of this. If you take just take a flower, okay, and let's just say for your quantum mind, for alphabet's sake, Cyrillic alphabet's sake, there's 33 petals, okay, and each petal represents an outcome. You guys understand string theory, I'm pretty sure. So now, square that in every single aspect, in every single derivative, not just in the function itself, in every single input of the function. Square every single input, and then after you're done with that, put it all underneath 1. And you could begin to understand the shadow aspect, mathematically speaking. We're not gonna get into the 9-inch Nietzsche side of this conversation, which is quite disturbing when we talk about the time continuum. We will end this video here, and we will go on to the rest of the entire depiction. All right.